It's partially true, but there are a few good reasons to listen carefully today. First, we need to realize a difference between blockchain and the cryptocurrency. The blockchain is decentralized technology, and the cryptocurrency, like Bitcoin, is just one example of something that uses blockchain. It's true that the first useful implementation of blockchain came with Bitcoin, but now there is a lot of other implementations of it, and it works in other areas. Second thing, blockchain makes many new crazy ideas workable. For example, you want to buy insurance that your flight arrive on time, but you don't have time for formalities. You just need to send some money to proper account, and if something bad happens, the compensation back to you. You want to buy green energy from solar farmer? No problem, there are working solutions for that. Or you just to send some money to your granny, which says that the bank cheat here, and she don't trust a local postman. I only need my phone and I can send a transfer to her. If it's not enough for you, blockchain is starting to be the hottest technology in the startup scene. Every beginning entrepreneur looking for use case to implement the blockchain in his startup. I must admit that some of these ideas are crazy, but some of them looking good and can be a part of our lives in the nearest future. At last, I must say that using blockchain and Java, using Scala and Java in blockchain ecosystem is a relatively new thing. Most of all the cryptocurrencies are implemented in C++ or JavaScript, and makes it complicated and very demanding for developers. In last years, blockchain started to spread and will be starting to be implemented in the other sectors than payments. In FX, projects are bigger and more complicated. That makes the architects and developers looking into modern languages and frameworks like Scala. And I think this is a great professional opportunity for developers which sits on front of me. And this is a plan for the rest of the presentation. First, I show you some theory how blockchain works, and later we will switch into code editor, and I show you a live demo of making blockchain app. I promise that I make the first part as short as possible, and we will go into code as soon as possible. First foundation for blockchain is a classic peer-to-peer network. In the simple situation, all nodes store the same state and same set of informations. It means that you can send event to any node and network will transmit it internally. Of course, there are a lot of mechanisms that keep network consistency and safety, but we don't need to worry about it. For now. Second important concept for blockchain is a block. Block is a wrapper around a set of transactions. Each node collecting incoming events and continuously trying to close it. There is a special, the process of closing block is named as mining or forging, and it's based on special algorithm that guarantee that blocks are mined on the random nodes. When any node mines the block will be retransmitted to another nodes, and the events contained in the block are marked as proper and immutable. The last crucial thing that makes blockchain working is a cryptography. Each event and each block must be cryptographically signed. The digital sign on event allows nodes to identify event emitter, For example, in case of cryptocurrency, you can identify coin sender. Sign-on block have other function. It guarantees that block is immutable, and this is needed by the consensus algorithm in the network. Everything what I showed on the last slides can be considered as blockchain 1.0. In practice, that means that we know in advance the network purpose, the event types, and we can hard code the business logic and validation rules in the source code of Node. Of course, there is an improvement of this idea, named blockchain 2.0 or even 3.0. Where we have added features like smart contracts, user-defined data types, or replaceable logic. In effect, we can run distributed apps on existing blockchain. The apps that run on the same blockchain can communicate and build the bigger systems. To keep today's presentation simple, I will stay with the classic blockchain idea, and we will hard code business logic in source code. From the programming perspective, programming blockchain app is very similar to programming app based on CQRS. CQRS system and the blockchain store and process events. Blockchain and CQRS system have different models for storing events and modifiers. For example, if you want to modify anything, you need to prepare modifier event and send it to processing. And the final object state is computed on the base of received events. Only big difference between classic CQRS system and blockchain is a level of events confidence. In blockchain, there can be anomalies, planned or malicious, and we need to protect our app from them. I think it's enough theory for the first lesson, and now we can switch into code editor and build the most famous app, to-do list. Okay. I prepared a seed project for today's presentation, and it is available on my GitHub page. The project, we have some weak internet connection, so we need to stay offline. The project has two branches, seed and master. Seed contains the project that we have now in the editor, and master contains the final effect of the demo. Maybe now we will switch into dependencies. Of course, we have limited time of knowledge, so we need to use existing framework to build our app. I choose the Scalar framework. It is implemented in Scala and is quite simple for us. As you see, we are using the newest snapshot. It's because the project is under development and there is the development team still making the breaking changes. The functionals that the Scalar offer for us is the actual blockchain technology. That means the physical format, validation rules, and things like that. And the bookkeeping system to packing and wrapping the events into the blocks. The mining system that makes the mining or forging possible. Scalar also provides consensus system, which is the most complicated part of the whole framework. It needs to detect the malicious activity and protect us and our system from it. Of course, there are also a cryptographic all the elements are parameterized. For example, here we're using the public key proposition and base event. Base event is our event that I showed a while ago. Okay, if we implementing to-do list at the beginning, at the beginning, we need to add a place for storing title and the tasks in the list. And we store the title in the string and tasks as sequence of the strings. We need to, if we want to see it in the REST API, we need to add two fields for it. Our app still compiles, that's good. Okay. Next thing that we need to add is a new type of event that allows us to modify the to-do list. The first command that we need is a command to create new to-do list. replace the new command on the one of the existing. We need to pass the title of to-do list here and the tasks. We need to modify the rest of fields here. And this type M is a type of our events, and it must be said. Unlocker is something. In this case, we have a command that creates something that we only creating new boxes here. The single command creates single box. But sometimes we can, with one command, we can create more than one thing. And this is use case for this sequence. Nodes should be random, but we simplify things and set it to 1. 1 is also a random number. It's not a forgery. And now the title and tasks. We have missing serializer. Each event type needs separate serializer. Like you see, this is a very dynamic implementation. But for we have limited, like I say, we have limited time, so we stay with it. Today we will run the blockchain on the single node, then the serializer will be not used in the practice. I developed it in this manner because preparing the biserializers is very demanding and we don't have time for it today. Oh, great. Our code still compiles, so once we can try to run app. Maybe we can change the type of simple box into 2. Starting. state we take in storage, and filtering the boxes. There is something that forger box. Each block containing the forger box, which is needed to make things running, but we don't need to see it. The next endpoint, getting single to-do list, and the last one is used to create to-do list. Here we extracting things from the JSON. Sorry, that's for its after code. And later we will signing we are creating to-do event and signing with keys which are available in our vault, in our wallet, which is stored on the server, on the node. Oh, sorry, missed something. We need new object and applying method. Maybe I can copy it from the final version. We also forget to add new modifier type. Each event like the create to do event, the box initializer event, and the block is a modifier and needs a separate flag, like here. In this framework, our flags are byte flags, so it's quite unreadable. Okay, we have this. We added a new apply method. Like you see, the event needs to be signed, but so on the beginning we are creating to-do event with fake signature, and we compute a message to sign from it, and later we will sign it with our key. This is okay. We also added a new modifier ID a while ago. Here, and we need to register it in our application. Like this. Modifier type ID, and it should be mapped to proper serializer. It is needed to prepare proper communication between nodes, but in this version we have only one node, so it works even without it. Okay. We also prepared this to-do API route, and we need to add it to application. Our application is a simple app. Okay, our node started and trying to mine something. Now now we have only Genesis block because the node is restarted and we don't have any backend to store previously mined blocks. Okay, now we have 2 blocks. Maybe we can try to add some to-do list with Postman. Tasks. We need to buy X and this. Send. Okay, we have response. The event was created. The type is incorrect because we don't change it in the JSON supervisor, but it should work anyway. And we can now check the chain. One of the blocks containing our event, and it should be available on the to-do list. Something bad happens.
Are you calling additional too long method on title?
Sorry?
You're probably calling additional too long on title string in your case class, I think.
Maybe yes. Okay, maybe. We don't have time to fix it, so I will switch to master branch, which is containing the working version of application. Okay, now we can. Okay, here we don't have any to-do lists. We are creating one with tomatoes. And now, oh, we don't have lucky to. Maybe I show you one of the browser. Because the last. Okay. I will show you a final effect because the Postman crashed and wants to start. But you need to trust me that it works yesterday. Okay. Thanks for your attention. And if you have any questions, ask it in the outside because we don't have time for it now. Thank you.